You know, we're very, very lucky here. I mean, when I wrote this book, I thought, you know, who are the great heroes of it? And Dr. Kahn and Vint Cerf are among them, and I hope you appreciate how cool it is, especially for somebody like me who loves history, to be able to talk the internet with you all.
Well, it's a real pleasure to have you here and to have the rest of you here in our new offices. For those of you who came in more on time, we kind of started just informally. This man sitting next to me has had quite an interesting history, so I'll repeat a little bit of that. He's currently the chairman of the Aspen Institute.
Good to see you.
And was formerly the chairman of CNN, was also managing editor of Time magazine, and has written a whole bunch of books, the most recent of which you have before you, The Innovators, but the most recent before that was Steve Jobs' biography, and many others before that, all of which are well worth reading. So we welcome you to our presence and to an opportunity to ask you some questions about this book. Sitting over on my right is Bob Kahn. I was going to say the late Bob Kahn, but that would be in bad taste, so I won't do that.
It wasn't that late.
It wasn't that.
Your problem is your garage says it closes at 7 o'clock, so we're about to go find some other garage to park at.
Well, you know, since we're all here, I can make the door open for you. How's that? You always wanted to open the door.
All you have to do is say, "Okay, glass, open the door."
That's it. Yeah, we can get. I'm wearing one right there.
Is the audience all from Google?
No. These are people from all over the place.
Who's from Google?
Fair number, but not everybody.
Okay.
So what I thought we would do, Bob, is start out with a couple of questions about the book itself and what Walter has discovered. This thing covers quite a broad range of topics about things that were highly innovative and made huge changes in our history. So what is it that you would distill from what you've already discovered in writing the book that you would like us to take away?
Thank you. And let me say that when we get further along and we're discussing the internet, I'm going to turn the tables, because to be able to ask questions of the two of you about both the ARPANET, the RFCs, and then the internet protocols. So watch out. This is going to be a two-way street.
Fair enough.
The main thing discovered, I've written biographies a lot. You know, Steve Jobs, Einstein, Franklin. And those of us who write biographies kind of know in the back of our minds that we distort history with the great man theory of history. We make it sound like there's a guy or a gal in a garage or a garret who has a light bulb moment and innovation happens. True innovation, and there's no better example of it than the ARPANET RFC process and then the TCP/IP process, really comes from pairs of people, teams of people, and from collaboration. Bouncing ideas off against each other, finishing each other's sentences, and the internet age in particular allows such teamwork and collaboration. The other thing was, I started this book when I said way earlier in this, before we started, we were talking about when I ran digital media for Time Inc. in the early 1990s, and I first met Vint when he was at MCI, and I was trying to convince Time Inc. to do things with the internet. And so the president of Time Inc. says to me, "Well, who owns the internet?" And so first of all, I think to myself, so I don't want to get fired, that's a clueless question. I say, nobody owns it. He says, "Well, who built it? Who created it?" And I realized, after thinking how clueless that question was, that I did not really know. And if you feel detached from the history of the things you use, there's sort of a detachment that leads to you not feeling comfortable with things. So I wanted to know, how did computers happen? How did the PC happen? How did the transistor become the microchip? And then how did the internet or digital packet switch networks come into being? And so that's why I did this book. And in doing so, as I said, you learn about the importance of collaboration, but you also learn that there wasn't one person who invented the computer. And certainly, even after doing this book, you and I have been discussing some of the, I should get more credit type feelings, but it was done creatively and collaboratively.
It's this notion of collaboration resonates very well with all of us at Google, because a lot of the tools that we make and use are exactly collaborative elements. I mean, things like shared documents, things like the Google Hangouts and things like that, where multiple parties can communicate all at the same time. So,
And that was the original intention of the internet was, or ARPANET, was time-sharing research computers and then collaborating. I even did that with this book. When I was writing that, I said, wait, this is how we collaborate. And I put parts of this book online, like on a Medium or Google Docs, whatever, and said, everybody share, help me collaborate, help put stuff in. And people like Stuart Brand, who I knew, started rewriting the Demise of the Whole Earth catalog and exactly what drugs were being served at the Demise party, because I got the drugs wrong. But people like Dan Bricklin were explaining, no, VisiCalc was done this way. And so they're in the book from having been crowdsourced.
Walter, I'd like to ask you a question. Sure. Vint and I were both on a panel at the National Academy about a week ago. And one of the questions that came up was sort of, what is the internet? And one of the panelists took the position that the internet is what people think it is. So if you think the web is the internet, then that's the internet. If you think the web is this. I just wondered, do you care much in writing a book like that of clarifying that example? Because a lot of places in the book you say, well, the ARPANET morphed into the internet, and not exactly clear what the internet is from reading your book. Mm-hmm. And are you comfortable with that notion of the definition?
And now I'm going to turn to you because you should answer it better, but I see it as the TCP/IP protocols. Now the question is, when Tim Berners-Lee puts a layer that has sockets that have HTTP, hypertext protocols and markup languages, to me that's still the internet. Now the question then becomes, if I'm using Twitter, is that the internet? And the answer technically is no. I mean, that's done.
Well, actually, we could argue that.
Oh, we could argue it. So let me turn it back to you all.
Well, wait now.
Okay, sorry.
We've gotten all the way to chapter, you're right in the middle of chapter 6. And I wanted to at least point out to you that, well, we don't have to go through every chapter, but look, this starts out with Ada. Ada Lovelace, who was Lord Byron's daughter. And I wanted to start out by just asking, what was it that drew you to that story first? Because it's in the 1850s in England, and it's the earliest manifestations of mechanical computing. So what made you decide to start there?
To me first was my daughter had not written her college entrance essay, and my wife, who we've talked about, was going nuts the way, yuppie wives do, and saying, get it done. And one day Betsy said, I did it. I said, what was it on? She said, Ada Lovelace, because she's a computer geek and stuff. And I paused. I kind of knew the name Ada Lovelace, but I didn't know exactly what she did.
You didn't mix it up with Linda Lovelace.
No, I did not. But, and so I'm surprised that people old enough in this room to remember who she is. So I became much more interested in Ada Lovelace. Now, Ada Lovelace is partly a symbol in this book, because as a person, she's kind of controversial. But what she does as Lord Byron's daughter is her mother, Lady Byron, was not particularly fond of Lord Byron by the time Ada was growing up, for reasons that Byron fans will understand. And so had her tutored mainly in mathematics as if that were an antidote for her becoming a romantic poet, which Lady Byron did not want her to be. So she embraces what she calls poetical science, this ability to link the poetic and the beauty of humanities with the technology of science. And she loves, for example, traveling the Midlands and looking at the punch cards that are being used in the mechanical looms of the Industrial Revolution of the 1830s. The Jacquard loom, and showing how they weave patterns. Her father, Lord Byron, was a Luddite. And I don't mean that figuratively. His only speech in the House of Lords was defending the followers of Ned Ludd, who were smashing these looms because they were putting people out of work. So, and he also is there with Mary Shelley when they do Frankenstein's monster. This notion that technology can destroy us was sort of ingrained in Lord Byron. Being Ada felt the opposite. She had this friend Charles Babbage who had made a pretty good calculator called the difference engine, was trying to conceive one which he never got built called the analytical engine, which uses punch cards to do the processing of the numbers. Ada writes a set of notes that are totally fascinating. You got to read them. And among the notes to this thing is how if you use punch cards, the machine will be able to weave patterns like Jacquard's loom, as she puts it. In other words, the machine will not only do numbers, she says, you can make it do words or even music. Like you can feel her father rolling over in the grave.
This is 18.
Patterns, anything that can be notated in symbols, she says. So to me, that is the core notion of what a computer is anything that can be notated in symbols. Then she has many other things, but I'll only mention one, which is her final note, is that they'll do anything but think. Machines will never be creative. Machines will never think. And 100 years later, assuming you're going to jump there, Alan Turing, who really comes up with the concept of the universal computing machine, then works at Bletchley Park to break the German Enigma codes with some people. They build the bomb and then Colossus. He writes a wonderful paper that the movie's about to come out called The Imitation Game, but he called it The Imitation Game. We now call it the Turing Test, to address what he calls Lady Lovelace's objection, because Turing was fascinated by Lovelace. And he says, well, you say machines will never think. How would we know that? If you had a machine in a different room and a person, you couldn't tell their answers apart, you'd have no empirical reason to say machines don't think. And so he believed in artificial intelligence, that eventually we would have machines that think without us. And I basically use that as one of the framing devices in the book, the notion of those who believe that the intimate partnership between humans and machines will get us forward, and those who believe that the pursuit of artificial intelligence will get us forward. Sorry for the long answer.
One of the first programs that I ever used, Vint actually wrote one about Parry and the Doctor. This is about the Doctor program. It made some outrageous statement, and it was supposed to be a conversationalist about, about you. And I remember when I saw that, I responded to it, my oh my. Yeah. And its response back was your oh your question mark, and I knew we wouldn't get very far from that.
Well, with all due respect to my Google Android's ability to talk to me, it is really hard to do language processing. So.
Yes, we have a lot of people who will confirm that.
And we know quite a bit about it.
That's right. No, you know more than anybody.
The earliest experience I ever had with trying to do language translation was at Stanford when I was an undergraduate in the 1960s, and we were pretty naive. We had this Russian-English dictionary, and we poured it into the computer, and we typed in out of sight, out of mind, and we translated that into Russian, then we translated it back into English, and it came back invisible idiot.
Yes, right.
Which told us that there was more to this than
But that, by the way, the book ends with a chapter called Ada Forever, which is what you just said, this notion of understanding a bit of language or being able to spot your mother's face in Grand Central Station, which if you go to the Total Domain Awareness System down in Lower Manhattan, they have all these cameras, and they say, oh, we can't do that, or a robot that can walk across the room and pick up a crayon. A 4-year-old can do it,
yes,
but a machine can't. I mean, it's called Moravec's paradox.
It's getting better, though. And
it's so, always getting better. And it's always 20 years away. It's always a mirage.
Look, the latest Tesla announcement, the D thing parts itself. So, I mean, we're getting closer and closer to something useful, even if it isn't as fully creative.
I was on stage yesterday with Elon Musk, who told me that the singularity is so close he wants to go to Mars because machine learning will make machines want to destroy us. And he's smarter than I am. You all at Google are smarter. But I've been reading that since 1955, right after Alan Turing does his Turing test. And they always say, 10 years from now, we'll have machines that can think better than we do. Maybe so, but as the heroes of this book, Lick Licklider, Doug Engelbart, Alan Kay, say, in the meantime, let's make our machines connect to us better than try to outthink us.
Well, let's make partners out of them, if
That's
nothing
what
else. And I have to
is.
admit, Google Search is a pretty cool partner when you think about it.
And Google Search is done not by an algorithm that thinks without us, but an algorithm that harvests millions of links put every day onto websites by humans.
I wanted to ask you one question about something that that struck me when I first really understood what Turing and company were doing at Princeton. I gave a keynote at the 100th, I guess,
Anniversary
the 100th anniversary of his
Turing,
birth.
right. His birthday,
this
right.
last-
I actually
last year
saw
or
your
two.
keynote, yes. Been
So
online.
it was one of a
Big
multiplicity
conference.
of them. But one of the things that struck me back then was when Turing wrote that paper on computable numbers, that was actually not easily accepted by people because they didn't think computing was something that a machine could do at that time, really. I mean, if you looked at what Church did with the lambda calculus,
Right.
it was a conceptual thing. If you looked at what his colleagues, like Kurt Gödel, and there were a number of really excellent logicians there at the time, they were thinking of conceptual frameworks for organizing things, so the
Yeah,
logic
you have to
made
remember
sense.
that, as you do, uncomputable numbers was not written to invent a universal computing machine. That was just a thought experiment he uses to solve one of Hilbert's
So what-
mathematical
That's right.
questions
What-
about whether
Decidability, right.
all problems are decidable. Yeah.
But it seems to me that the one thing that really came out of that was the idea that you could actually create a machine that would do these computations. They eventually showed that, recursive function theory and the lambda calculus and the Turing machine all could do all the computable
equivalent thing, yeah.
functions, but that wasn't known at the time, nor was it obvious. So it's the realization that it pops out at that time that you can actually build something around these numbers that
But
was
what's
so
interesting, and I
fascinating.
don't
But I
fully-
didn't get that out of the book, and I wondered, was that something you just didn't think the public would understand, or was worth?
I didn't think that, I thought that was a important, totally fascinating. I drilled down, read the entire Turing thing. That is a sidelight because it's not about the actual, what they were doing at Bletchley Park, which I was trying to
That's right.
tell.
This was at Princeton.
Right, but I would love, what happens there, and I'd love your feedback on it, is they are trying to figure out whether all problems are computable, whether it's decidable to know which ones are not. And you end up with Gödel saying there's an incompleteness inherent, and with Turing and Church both saying, and we can't even decide what is completable and what's not completable. I'm oversimplifying. So there's still a mystery that's wonderfully inherent in math, that not all things, there is an incompleteness in any mathematical
But
system.
it was also the fact, I believe, that what Turing had done was not appreciated that much by the other people around him because they were the pure theoreticians. And Turing was more of an engineer, if I can use that term,
Right.
even though he never built anything. Much like the conflicts that we've seen in computer science in recent days between the people who are the pure theorists
Yeah.
and the
The
people who are
No,
actually
you're
building
absolutely
stuff.
right. And of course, I do say in the book that there are only 4 or 5 people who even comment or review his paper. It's not very well thought of. And throughout history, you see that where Penn, they're building these computers, and yet it seems a little beneath their dignity because it's not an academic, theoretical pursuit, and so then they get rid of the computer. And even at Princeton, if I may say, the IAS are finally, after von Neumann leaves, they don't feel computing is a grand endeavor in its own way.
Well, there was physics.
Yes, right.
Well, everything's physics when you get right down to it. Right?
Everything's math.
Well, okay, all right, so we start with math and we go to physics, and the abstraction of physics is chemistry, and the abstraction of chemistry is biology, and the abstraction of biology is psychology, and it keeps on going like
But
that.
you remember the symposium we had up at MIT when Richard Feynman came and a bunch of others, and it was called The Simulation of Physics?
Yes.
And they didn't like that one
Yeah.
bit because they said physics is not a simulation. It's
So I
not some
want-
bigger digital thing that's creating
You're
it.
losing control of
Yeah, I
us.
want to come back to a couple of things. Yeah, well, it's
Okay.
impossible.
Life is
Nobody
a-
can manage these guys.
life
But I
is a
do
learning
want to
experience.
draw you back for just a couple of seconds. First of all, the point about Turing, for example, reinforces the notion that theory is helpful if it can underwrite or underscore or somehow support applications. If you don't have much theory underneath the application, then you don't quite know what to expect and what you're doing. So it's clear that the Gedanken experiment that Turing did is not unlike the Gedanken experiments that Einstein did. A lot of his work was not math. It was Gedanken imagery. He thought in those terms.
Visual thought experiments.
So now let's go to something more concrete, though. You have a really interesting story here about what happens when the transistor gets built in 1947. And the three guys who do this go off, and well, Shockley anyway, goes off to start a company to build transistors. And I think it's worth recounting what happens, because the focus that we got to early in this game was collaboration and what happens when you get groups of people all focused on trying to do something. So what happens in that case? Shockley goes to the West Coast and starts his company, brings some really smart people together, which should have produced an important collaboration. But what happened?
Yeah, I mean, it goes to the theme of the book, which is that vision without collaboration and execution is just, you know,
It's hallucination.
And what you have at Bell Labs is this wonderful environment where Shannon is riding a unicycle up and down doing information theory, but you
Did
also
you
have
do that when you were there?
Yes.
Shannon had left when I started my career at Bell Labs.
No.
And one of the things I got from your book that I found very interesting was he started at the same place that I did, which was 463 West Street in New York.
Right on Greenwich's Village's side of the
It was
Hudson.
right on the Hudson River, and you could watch the Queen Mary and Queen Elizabeth coming in every Tuesday and going out
And
every
these
Thursday.
it's still a wonderful warehouse, and then they moved to New Jersey. But
Murray Hill existed at the time that I
Right.
was there. I don't know if I think
yeah,
probably did
and
when
it
he
becomes
was
a
there.
cauldron in which you have information theorists, quantum theorists like like Shockley to some extent, and certainly Bardeen.
Bardeen, for sure, yeah.
Walter Bratton, who's a great experimentalist, but also people with grease under their fingernails who've climbed poles to figure out how we're going to amplify a phone signal between New York and San Francisco. And they collaborate. They work together. They have a little bit of a problem when once the collaboration is over, does Shockley get to be in the pictures with Bardeen and Bratton, and who gets credit and who gets a Nobel Prize? But before you fight over Nobel Prizes, you collaborate well. Shockley was really bad at collaboration, and he got worse, and the Nobel Prize didn't help. I mean, so I'm glad we've not all won one yet, because it made him into a bit of a jerk. And he goes off and he forms Shockley Semiconductor, and he gets more and more uncollaborative with his team, and more top-down dictatorial, unlike, say, a
Or
Google
even
environment.
hiding his research
Hiding
results
his
from other
research from
people.
his own people, making him take lie detector tests, worrying who's going to get the credit. So obviously, the great thing about it is it disintegrates because of this. And the people who fly off from this Big Bang are so allergic to Shockley's way of doing things that they move to the other extreme. Two of the best examples being Gordon Moore and Bob Noyce, who formed Fairchild Semiconductor and then eventually formed Intel.
Why was it called Fairchild Semiconductor?
Because they did not have venture capitalists back then. So when they started they wanted to start their own semiconductor company, but they couldn't just go to Sand Hill Road and tell Kleiner Perkins, give me an investment. Arthur Rock was just starting, and so he helps put it together. Arthur Rock was not yet a venture capitalist. He was still a banker from the East. So he calls his East Coast buddies, IBM, Bell, and says, do you want a division we can start that will make semiconductors? And they all say, no, we don't want that, and we don't want an autonomous division. We don't want to give them the power. He's just about to give up. And then Sherman Fairchild, who's a bit of a nutcase and a playboy and always out at nightclubs and 21 Club. They make a deal, and Sherman Fairchild says, yeah, I'll stake you. I'll make you our Fairchild Semiconductor division. They were also doing cameras and aircraft. And, of course, it becomes the biggest division in the company. And eventually, Fairchild exercises the right to buy them out, after which Noyce and Moore start their own company, Intel.
That's amazing. So this is sort of like one of those black hole explosion things that...
Well, they call them Fairchildren because Fairchild then, breaks up a bit. And if you look at Silicon Valley, you can do a Google map and just say Fairchild, and you'll see all the companies that spun off.
There are actually two parallel stories with Intel and the work that went on before that are interesting. You focused on one of them in the book, and I knew two of those people very well. I've met Gordon Moore, but I knew Bob Noyce very well, interacted with him a lot, especially when I was doing the VLSI program at DARPA, and he was fighting the BISIC program in the DoD. And the other one was Andy Grove, who was in my class in undergraduate school. So I knew Andy
in New
at
York.
City College, yes. So I knew those two well. But the other story that's quite interesting is sort of who gets the credit for the microcomputer. Because
The microprocessor or microcomputer?
The microprocessor in this case,
Yeah.
because you have...
This is after the integrated circuit,
This
about which
is-
there was another
this
big
is-
argument.
That's right. This was in the early 70s.
Right.
When, Intel was trying to figure out internally how you connect one piece to another piece, and instead of doing a one of, they decided, let's build a programmable thing. So you have a guy named Federico Fagin,
Right.
who actually did the actual implementation of it. You had a guy named Ted Hoff, who is sort of credited by everybody, and Bob Noyce told me when he was pushing some of the nominations for awards for him that he was sort of the architect of the whole thing. But you had it all done in a lab that was run by a fellow named Les Videz. And Les always claimed that he set the environment and the tone which enabled it all to happen. And that's between the three of them, they don't really necessarily all see the development
It's a shame.
of the same
That
way.
happens a lot. And in this book, I'm already getting emails, and you are too, from, I won't name names because we're online, but
yes.
people say, he didn't quite give me enough. Oh, actually, now I've read it. He did give me enough credit. The one I love is Kilby. As you know, Jack Kilby does it at Texas Instruments, the microchip, which I'm moving back earlier, integrated circuit,
In 58.
and Noyce does it at approximately the same time and separately. And Kilby wins the Nobel Prize, and unlike Shockley, it doesn't go to his head. And he also says, if Bob Noyce was still alive, he'd be sharing this prize with me, that we both deserve it. And they don't give Nobel Prizes when you...
Kilby didn't get that award until he was 82, and he
Right.
passed away a couple
But when they
years later.
finally bring Kilby, and he's awarded it, the Norwegian scientist introducing him says, everything we have in the digital revolution comes from what you did. And Kilby says, that reminds me of what the beaver said to the rabbit at the foot of the Hoover Dam, which is, no, I didn't build it, but it is based on an idea of mine. So, I mean, people, one of the things about collaboration is it gets hard to allocate credit, and I try very hard in this book to say, okay, here's how I would parse the credit for the computer. I mean, is it basically Mockley and Eckert at Penn? Is it to what, Adam Assoff at Iowa State? Microchip, transistor, and we all want to parse out credit, whether we're intellectual property lawyers fighting over the patents, or whether we're Nobel Prize jurists, or whether we're biographers. And I try to minimize, and this is, you and I were talking beforehand, there's dispute amongst the people who conceived of packet switching, which are 3 or 4 or 5 people. They all fight over. They're very, they're all quoted by name. On the record, we'll tell you, oh, this guy's an idiot. But I try to say, no, it was the collaboration. Packet switching was an amazing idea. It is the heart of, obviously, what you two did. And I was slightly annoyed by the people who wanted to disparage their colleagues' contribution because there is enough credit to go around.
Exactly. And this sort of emphasizes several things. The first one is that a lot of stuff happens because it's now possible to happen. The economics are possible, or the amount of memory available makes it possible, or the speed of something makes it possible. And so concurrent invention is not unusual under those circumstances.
Especially, there's a miracle year of around 1939, let me say, where conceptual breakthroughs have happened, including Turing's paper is published on universal computing, but Shannon and others, people are starting to apply Boolean algebra to how to do it in circuits. But you also have sort of mechanical inventions, including the vacuum tube and telephone switchboards that have come together. But you also have the drums of war, and both in Germany with Hermann Zuse, and at Bletchley Park in England, and at Aberdeen Proving Ground in the United States. It's dawning on people that firepower is actually not going to be as important as computing power in winning the next war. And so that's why I'm convinced that you have a fertile ground from 1940 to 45 for the creation of the computer. And likewise, another fertile stew happens which is Google is part of it out in California, Mountain View and all, that in the early 70s, there was just this yeasty brew of counterculture types, electronic geeks, people who had been in the defense industry, people who had read the Whole Earth catalog once too often, all of whom are coming together and want computing power to the people to take it back from the big corporations. And they're creating the Altair and the Apple and all those machines.
I was waiting for you to leap into something.
Well, I have, so many thoughts going through my mind. I'm not sure where to jump into this. But, one of the questions I had about the book was, what prompted you to choose the things that you did to emphasize? It's a wonderful read. I mean,
that's the toughest of all questions.
And about the only complaint I have is that you couldn't touch everything with uniform treatment.
Yeah,
so, for example, there are things that don't show up here at all. Like, for example, the role that NSF played in bringing the internet out.
Right.
Okay? There are people who I think played an important role that never get mentioned, like Steve Wolf is a good example.
Yeah,
The
absolutely.
names just don't show up. I just wondered, this is a reflection on what you felt you wanted to write about.
Yeah,
And
I had
how
about
did you-
1,000-page book.
How did you get to this,
Right.
this
I mean,
rendition?
when I did all my notes, are about 1,000 pages. Wolf is in many other things. There's a certain limit in this day and age to books, which is approximately 500 pages. I mean, that's,
I've read books bigger than that.
I know, but I meant there's not many. I mean,
I read Gödel, and Bakken.
what, 600 pages? Not much
I think
more.
it was more than that.
Okay, that's a good book.
One setting.
So, yeah, but you know what?
Took a long
Not
time.
everybody can read Gödel, and Bach in one sitting.
No,
You're not the best focus group for the publishing industry. But I did decide, hey, I want to keep it in a package. And I'm going to get to why we don't need to do that in the future. So I ended up picking 12. I just made a list finally at the end. 12 major things I wanted to do. I wanted to do the computer. And so I focused on those people. I wanted to do, and by that I mean the people who really began it, not Controlled Data Corporation and others that pick it up. I want to do the transistor, the microchip, video games, because I actually do think that they were important in the interactive computing realm. I wanted to do software and how original operating system software and the women as well as men who did it. And I go down the web and others. I could have picked many other things. I could have picked many other people in each one of those categories. But I said, okay, who made a conceptual leap that I really feel passionate about? Now, I know that leaves out more than it includes, but it makes for a narrative. The problem with narrative history is narrative is defined by you leave out a lot of things so that you have a thread.
But that's really interesting, because if you focus it all on the conceptual leap,
Yeah.
you minimize the contributions of the people who actually then implemented those ideas.
Right.
And as an engineer, and I think Vint would agree with this too, a lot of the details are in making things actually work.
Right, and as I
So how do
really
you-
try to
how do you
emphasize in the
juggle between
book,
those
that you
two?
have to execute on vision. And that's why I focus on the engineers and the software engineers of ENIAC more than on this conceptual leap that Adam Nassoff has in Iowa State, because he doesn't implement it. And I hope, I mean, you can be the judge, that with Fairchild and Intel, we get into a lot of the, engineers who are making it. Let me leap forward to what I hope is the solution to this, which is I would love it, and Google is the best place to invent it, with Google Docs, networks, everything else. And I've tried. I've worked with people. I'm still not there yet. But I would be quite happy to take this book and make it a curated wiki
That's interesting.
Google Doc.
That's interesting.
And I have done that with some of the chapters. It's why Dan Bricklin, you say, why is Bricklin in there for doing VisiCap? Well, frankly, because he gave me all of his documents when he read an early draft, and it was on Medium, which is a place, which is like a Google Doc place where people put it in. So I would love to, I think the book of the future will be a collaborative, crowdsourced, and yet author-curated, meaning you just can't run off anywhere. Multimedia, where let us say you want to talk about, let's pick one thing, how the planar process worked and how the planar process led to the microprocessor being easily invented at Intel. I would love the videos, I'd love the original documents, I'd love people to upload those things, because online, on a Google book, I'll call it, you could make it not 500 pages, but 500,000 pages and video.
Is that still your book at that point?
And that's why I would like to curate it. And here's, I mean, meaning that, you know, you're going to have fights. I won't name names again, but you can, even with your friends who were originally there with packet switching, just like the revision wars in Wikipedia are fought with more intensity than we seem to be fighting wars in the real world these days, you would have to have some curator who would say, okay, enough of this fighting about who came up with packet switching, let's try to just put it all and synthesize it. But I suspect, like Wikipedia, the crowd would also curate pretty well. I also think, and this is the next thing I would love Google to do, for that to be really fair, there has to be a payment system. I mean, I would be happy to put this book online with, shouldn't say this too publicly, but after Steve Jobs, I'm not looking, for more book
sales. This only just came out, so don't say that to your publisher.
That's right. But let us say that Vint, Cerf, and Bob Kahn looked at this and said there are 22 things you really left out of the RFC process and the ARPANET and then the TCP/IP process we went through in '73, I think it was. And here's all our documents, and here's somebody who should have got more credit. Here's his picture. Here's an interview I've just done with him. I want to put all that up. You would be doing that as you would be editing a Wikipedia entry just for the good of the commons. But there'd be other people who might want to contribute and actually make a living out of it.
So this would be like sticky notes on your book?
Well, it would be like making my book into a Wikipedia page where everybody could put up documents and stuff. And I would love the royalties to then be allocated in some cryptocurrency way that Google could invent, so that if people are paying $30 for this book and they read these parts, the royalties get allocated to whoever contributed.
So that's a challenge before us.
And I hope my next book, I mean, I'd love to write about Louis Armstrong, but you need music. I would need a Wynton Marsalis to say, here's the 17-bar cadenza that opens West End Blues, and here's how he changed it from King Oliver's version. But that would need to be crowdsourced and multimedia, and I want Google to invent that.
Well, I always thought that one of the really nice things that historians rely on are crafted treatises on various topics. There's a lady that Vint and I both know who wrote some monographs on infrastructure development. She would not write a single sentence in there that she couldn't curate from some well-known historian who quoted something and made a point. So how do you treat something like this when the only real authority behind it is the party who put it all together, and everything else is all this other stuff that's stuck in
this
there?
is much more footnoted, source noted than, say, the Steve Jobs book, which mainly came from interviews with Steve and 60 or 70 other people around him. I am probably not the best reporter in the history of the world. I just saw Bob Woodward when I was walking here. He's much better. I'm probably not the best academic historian. I mean, somebody like you just talked about who does that. I do have, I hope...
Yeah, but you write so well.
Well, thank you so much. But I also have, I hope, the ability to combine historical research, like looking at the monographs or whatever, with just being able to call Gordon Moore and saying, I'm going to get in a car, I'm going to drive to Woodside, you got to spend all day with me. And I'm lucky, because I've been at Time Magazine. That Gordon Moore, who would not take the phone call of, my second cousin from Louisiana, if he said, I want to drive up to Woodside, I get to see these people. So I do a lot of interviews. There are about 100 or so, including you and others in the book. But I also go back to the papers and the IEEE and everybody, your great document on the invention of, your collaborated document on the invention of the internet. The original Glenn Kleinrock and Paul Barron papers. I do try to put, there's no quote in this book, I think, or no major quote in this book or assertion that's not source cited by name on the record. But it's, all history is just the next draft of history. There'll be people who will build upon this. I think I bring some journalistic skills. Other people bring better historical, Jane Abate, others who have done great academic histories of the internet. And someday when it's all part of this curated crowdsourced system, you'll be able to hop around and get whatever you want.
So I have a suggestion. He was threatening to turn the tables on us, so maybe we should do that. And I'd like to let everybody else have some time to ask
You're trying to
questions.
filibuster against that?
No,
Well,
I'm trying
figured
to.
I managed to.
I'm more used. I have spent 30 years as a journalist. I love asking the questions. Here I am, having the people actually invented the internet ask me questions. I'm going, that's wacky. I should be asking them questions.
Well,
So
actually, when you read the book, the impression that it gives, which I thought is the one you were trying to give, is that collaboration is really everything, and all these people really created the internet.
right,
Well, but that's
and I really wanted to.
right.
I really wanted to, and it is true. I'm trying to show collaboration, enough credit to go around. And it is true, I sort of think, and then afterwards people say, you didn't give me quite enough credit. Or worse yet, they're suing Sperry, over the patents. But generally, collaboration is really cool. And I'll start, there's two real segments of the internet.
So when you point out Vint and myself, what makes you single us out? I mean, we can give you our views, but I'm wondering.
I
we have to
will,
live
I will
here. I mean,
turn it around and make you give the views. I'll say that there's two great phases in the creation of the internet. Phase one was the creation of ARPANET. I think you were at BBN probably.
I actually was a system designer.
Yeah, at BBN, right? Both Baranek and Newman, which was a private company, but still very associated with MIT
Right.
and
And
to some
Harvard.
extent, and
And
Harvard, and to some extent with the government, because you had from Larry Roberts and I guess the original Licklider, you had contracts to do what was unfortunately named IMPs, interface message processors, which,
Why is that unfortunate?
well, because when BBN got the contract,
I actually had the little slide that Ted Kennedy sent.
yeah,
And he,
I'm going to do a Ted Kennedy joke here, which I'll let him, I'll let
finish.
Dr. Kahn do the punchline.
I gave it to Licklider's wife at the ceremony.
Wait, let him do his punchline.
Well, they don't know the joke before you
It's
do the
his
punch.
punchline. Go ahead.
So it's the interface message processor, and it's awarded to BBN, which is in Ted Kennedy's district, and he sends a telegram congratulating you on getting the,
Interfaith message processor.
which, by the way, is a wonderfully telling slip,
Yeah, yeah.
because it was interfaith in many ways.
Well, actually, he thought he was congratulating them on what he thought was an ecumenical effort.
It was. It was
An
the
interfaith
ultimate
message
ecumenical effort.
processors, the
We call
the
them,
Jews
we
and the
basically call them routers
Muslims and
now.
the
But these were
Catholics
the
and the
machines that were going
Protestants.
to,
Actually, I would say we call them packet switches now.
yeah, but these were the machines that would be sent to the original nodes on ARPANET that would sort of be an interfaith or interface between the host machine and the rest of the network.
So Vint, you mean if it wasn't ecumenical, we wouldn't have gotten that thank you note?
I don't know. I mean, it's supposed to be something that was non-denominational, right? I mean, the whole idea was non-proprietary, and it was from Kennedy's choice of words, non-denominational, and that's very true. The IMPs were there, packet switches, to form this uniform, homogeneous network to deal with an extremely heterogeneous collection of computers that were on the edges. And that demonstration, to take your point about the this two phases of the whole process. The first phase demonstrated that heterogeneous computers and operating systems could be made to communicate across a homogeneous network. And that was the beginning of understanding of what was possible.
And it was the ultimate collaborative process, which is what I'm going to ask you about, because if somebody had to say, if you could show me the true nature of a collaborative process, this is early on, before we're getting to the internet, TCP/IP process, is how are these IMPs going to communicate with host computers and each other? And everybody kind of vaguely expected that either from the bosses of BBN or the bosses in the Pentagon, the word would be sent down. But instead, it's done collaboratively, mainly by graduate students, including you, a graduate student.
There are actually two parts of that process. the one that had the computers talking to the other computers was what led to the host-to-host protocols. That's one Vint was very involved in, along with another number of other people. And the second part that had to do with how the machines talk to these interface message processors was in a BBN report that I authored called BBN Report 1822. So that interface was all called the 1822 interface. And that was a combination of how the hardware would work, because you had different word-sized machines, how the software would work. And that was a precursor to having the machines talk to each other.
Right, and the one I focus on, because you asked why do you focus on things, is the request for comment process, because it was so collaborative and collegial. Even the phrase that Steve Crocker, who you turned me on to, and I went and interviewed for the book, he's just a graduate student with you, and instead of having the graduate student say, here's the way we should do it, he would write them, he said, I had to think of a name that would make people feel like they were collaborators in this. And so when we sent them out, I didn't want to say, here's our plan or our proposal. He would say, he was standing in the shower at his girlfriend's house, he said, and it came to him was that he should call it a request for comment, because it was so open and inviting as opposed to, here's what you're supposed to do. So you were in early, let me let Vint tell the story from there and then, but you were in early, you were in the RFC process, weren't you?
Yes, but to draw a little bit further on what Bob was talking about, in order to have communication at all, you need to have commonality. And so the 1822 hardware and software interface between the hosts that were heterogeneous and the imps that were homogeneous was the first important piece of commonality. The next piece of commonality is that the computers at the edges of the net needed to share something in common so they could communicate with each other, packet formats and protocols, handshaking, and so on. That's what Steve and I and others worked on, the host-to-host protocols. And Steve and I and the others, John Postel, were graduate students in Len Kleinrock's laboratory at UCLA. And we kept thinking that somebody like Larry Roberts, who was in charge of the project at ARPA, would come out and tell us what we were supposed to do. And he didn't. So, we thought, well, we have to do something.
He didn't know. He was expecting you to tell
Well,
him.
Len didn't tell us either. So basically, these graduate students are sort of scratching their heads saying, well, we have to do something. So Steve did a beautiful job, exactly as you say, of organizing this group, which spanned across a dozen different universities, looking at not only how to get the computers to exchange, postcards, so to speak, but also to build on top of that. So this notion of layering came out very early on in the ARPANET history. So we learned an enormous amount from that experiment. Email came along in 1971, 2 years after we turned the imps on at UCLA, Santa Barbara, SRI International in Utah, and BBN, where Bob was still, was pumping out imps, and they were popping up on the network one a month for quite a while. So we were experiencing utility from this homogeneous network and got pretty excited about that. So that's the first phase, as you say.
And to me, and tell me if I'm wrong, but the notion that you all did this through an RFC process, I found fascinating, because it almost seemed like it's ingrained in the genetic code of the internet, which is it's a collaborative system built collaboratively.
This, I think, is fairly important. Bob, I think you've been very articulate about this. Not only did we have a bunch of people who were shared this common excitement and view that we could make this stuff work, but the institutions that have been created arising from the ARPANET project and then the Internet project were equally bottom-up and collaborative. And this notion of multi-stakeholder models, where all the parties who have a stake in something participate in the development, whether it's the technical development or development of policy, infuses all of this internet environment. And I have to say that Steve's trailblazing.
Steve
Crocker's trailblazing. That's right, you would think Jobs, wouldn't you? Okay, so Steve Crocker's trailblazing, I think, helped set that tone. And all the institutions that came out after that had a very similar character.
So the counterpart to that, though, is that these computers were all linked together through a single network called ARPANET. And the process by which the ARPANET was built involved DARPA generally in the form of Larry, with a group that he coordinated with, essentially writing the requirement specs. You know, half-second delay across the net, 1,000-bit packets or less, and so forth. But the actual building of that net was much more insular than any of the other things that went on. In fact, it was almost, you know, a desire by BB&N to keep it that way. I was, in addition to playing a technical role there that was pretty important, I was the only one that was assigned to deal with the external community. That was my job. If anybody had a question, I was the only one they knew of, because nobody else was, they were not interested in having them be deviated from a very short time frame to get something done with questions from the community. And this BB&N report 1822 was one of the hardest things I ever wrote in my life, because I had to make a document that all of the sites that would connect had to be able to read and understand. And I had to solve their problems at the same time abstracting out everything about the net that they didn't need to know about. So it was an intellectual exercise of the first order to actually write that report in a way that it didn't get into so much detail that I get so many questions about, well, exactly how does the routing work, and exactly how the buffering work, and how does the error control work.
Well, you just answered the question of why I have to leave some stuff out, too, is that, you know, whenever you're
That's what I
writing
did.
something like that, you do. I want to ask you all a question before we get to the internet, TCP/IP, which is the next step, is there's a great controversy, which I show both sides of in this book, as to whether or not the ARPANET, I'll call it, was designed with partly surviving a nuclear attack in mind.
Yeah. You know, Vint wasn't internal to DARPA at the time, and I wasn't there when it first started. But I read a lot of the internal documentation on that and talked to a number of people. So there are 2 or 3 points of view on this. One is, and you call it out in your book, Charlie Hertzfeld, who Taylor likes to talk about the 10-minute story.
Yeah.
Really, and you clarify that it was really multiple years that.
I know, I hate clarifying stories that are so good you want them to just be told the way people like them.
And that one, and the Kleinrock story about sending the L and the O, that was years before we had the protocols, years before we had email systems and the like. So, but they're nice stories. So when it comes to the actual implementation, what was motivating the folks in the office was the economics of sharing computer resources that were very expensive. So, I can recall, like, Harvard got a big disk. At the time, it was like probably $1 million. And so some other university, like Carnegie Mellon, said, well, we need one too. Well, why spend another $1 million on Carnegie when they could share the one at Harvard and save DARPA some money? So part of it was the economics. But if you actually look at the documentation, it talks about needing to build this net to facilitate computer resource sharing. So there was some interesting technical problems. It points out that the network itself could have a big effect on communications. But this was at the office level. So there was nothing that pervaded the office activities that had anything to do with nuclear survivability or any of the military aspects. What Steve Lukasik wrote about, and he's written very clearly about this over the years, was that at his level and above, the reason they thought this was a good investment for DARPA to do was because it could have all of this
because
impact.
it's distributed. There's no central hub to the internet.
It could be reliable communications.
And it will route around any Soviet attack.
It could be a better solution for command and control and so forth. So to say that that wasn't there because the office didn't see it would be denying what was going on elsewhere.
If I may read...
there's a very funny exchange in here about that. Go ahead.
Oh, yeah, this is the one I think I'm
this
talking
is
about.
great.
Which is when Lukasik, who said, hey, we were doing it to survive a nuclear attack. You down at the office level didn't know that, but that's why we were funding it. And Crocker says, no, you weren't. So anyway, I interviewed them both.
Yeah, I know.
And,
Crocker changed his mind.
And Lukasik says, I was on top and you were on the bottom. This is what he says to Steve Crocker. So you really had no idea of what was going on and why we were doing it. And to which, when I told Crocker this, Crocker responded, I was on the bottom and you were on the top. So you had no idea what was really going on. And, that's the way life is sometimes in a collaborative process.
So I get to add one little codicil to this because the original work that Paul Barron did on survivable networks. The 11-volume series called On Distributed Communication was all about building a survivable command and control network. It was digital in nature, but it was carrying digital voice. And think about this, he's doing this around 1960 before we have integrated circuits or anything else. So he's looking at survivable command and control. Then along comes this ARPANET thing, and for many of us, it was a resource sharing project. Then internet comes along, and we should come to that. And I remember thinking, when it was my responsibility to manage the program, that we should actually demonstrate that the TCP/IP protocols would in fact allow you to survive a nuclear attack. So, although I may be jumping ahead a little bit, towards the end of my tenure at DARPA, we actually put packet radios in the strategic aircraft and flew them around and artificially disabled the ARPANET, broke it up into pieces, and reassembled it using packet radios in the air and on the ground using TCP/IP to demonstrate that you could actually make a survivable network.
And since women programmers don't often get their due in history, you had a great woman, Perlman, right?
Radio Perlman did a fabulous job of designing the routing system that would recover by figuring out what the broken segments were and how to glue them back together. She did a beautiful job.
Let me, Bob, if I may, leap to, I think it would be spring of 1973, if I remember correctly. And what you have is ARPANET, and as you say, I don't do enough with NSFNet, and there are other nets, and Aloha Net, and all.
Of course, they don't exist yet.
I want to stipulate for the record, I didn't think you could cover everything. So I
Okay,
was just
good. But anyway, but so
why
all
you
of a
picked
sudden
what
there's
you
a
did.
whole lot of packet switch networks, but they don't talk to each other.
There
One
were
of the-
only four.
Only four. Aloha
Yeah,
Net.
at that point, you had
Wow.
Aloha, you had packet radio, you had packet satellite, and you had Ethernet.
Ethernet, and then you had
Xerox PARC.
ARPANET.
And you had ARPANET.
So
There's
it's- okay, five.
Okay, five.
You're going at the story from the back end. I would like to tell it from the front end.
Tell it from the front end.
The front end was we had the ARPANET because DARPA had commissioned that. We built it. I then go to DARPA, and I show up there in roughly the end of October of 1972. And I go there to start a program in automated manufacturing, which the Congress later kills.
They're back at it again, though. I mean, automated manufacturing.
We're off
killing
the point.
programs.
Have you seen how the Tesla? Oh, go ahead. Anyway, go ahead.
So when they kill a program, I'm thinking, all right, what I signed up for here isn't going to happen. I'm going to go back to MIT where I had a standing offer to go join the faculty again because I had started my career out there after getting a doctorate from Princeton. So, and before going to BBN on a leave of absence. So I was thinking, Larry Roberts, who's running the office, persuades me, stay on, you've been so involved in networking, don't do that. And so I agree to give it a shot, but only if I can have nothing to do with the ARPANET. Because I did that before, I want to do something new.
Well, you
So-
would have been constrained in some sense because you were at BB&N and they were still a contractor and you can't manage them as a program manager after having
Yeah,
been at
this is
BB&N.
before we had conflict of interest rules. and laws.
Yeah, I mean, I got my own ability to manage conflict, so not a
No
problem for me.
conflict, no interest.
Not a
Right,
problem for
yeah.
me. So, but I finally said, all right, I'll give it a shot.
Yeah.
And so I was the one, I started the packet radio program after I got to DARPA, and I started the packet satellite program as a program. Now, let me just say, Larry had started to fund BB&N to turn a satellite imp into one that could use a satellite as a modem relay. And one of the issues that I had to deal with was that a good idea or not? And I thought, no, it wasn't. Let's make the satellite net a separate net by splitting it out. And this was an interesting technical discussion we had with BB&N because they were of the opinion that this would be much more reliable if everything was in an imp. But that meant you couldn't ever do the equivalent of putting a router in between it. You'd just lose complete control because everything was memory-to-memory transfers. So we ended up building a separate net on a satellite net. When Larry funded them, there were no domestic satellites at all. There was no plan to use the satellite anywhere. And so I ended up negotiating with ComSat and then an Intelsat to actually set up tariffs that would enable this to happen. And then we set up the program. And the one who ran that program technically was a fellow named Irwin Jacobs, who later became the founder of Qualcomm.
Qualcomm. Right.
And I was the sort of chief architect of the packet radio program, which became essentially the forerunner of today's CDMA
But the
technologies.
point is that you have all of these networks,
So
and
these
they
three-
don't interconnect.
These
basically.
three networks show up, and that was what motivated me to work on the problem of internetworking them. And I had some
And
architectural...
let me pause right there, because I love, when I heard the word internetworking, I said, I get it, that's where internet comes from.
That's
Is
where it
that
came
right?
from, right. And so I had that as a goal. I had some architectural principles. We knew about, we didn't call them routers then, I called them gateways. But, I came from a communications background. And so I was very comfortable with building things that could move the bits around, but I was less comfortable with what the computers would do with them when they got that. And Vint and I had collaborated a lot on the ARPANET side of things, me on the communications part and him on the computing part. And he knew more about how you embed these protocols into the end computers. And so I approached him at one point and said, look, here's what I'm trying to do, and here's a whole architectural approach. Here's what I really don't know. I don't know about what it will take in these different machines. And we agreed to collaborate, and based on that collaboration, I think both parts of it came out better. We were able to improve the communications part, we were able to improve the end part, and that collaboration, I've had many collaborations, but the one with Vint was probably one of the best, and we've stayed pretty good friends over the whole time. So
In spite of that, right?
in spite of everything, right.
But that, it really does show that this is
that's
a
where it-
partnership, this is collaboration.
But that's
how
where it came
creativity
from.
happens.
It came from the need to connect all these different nets. And
So explain how you turn that into TCP/IP.
Well,
we did it together.
yeah,
I know.
he did. He and I spent 6 months trying to sort all this out, and eventually this notion of gateway, this system sort of emerged out of requirement, right? You have a bunch of networks, and we weren't allowed to change any of them. And the question is, well, if they can't know that they're part of a distributed system, how do we link them together? The conclusion was you needed something in between that knew how to talk to both networks and would glue them together even though they didn't know they were connected. Then the other problem is that the hosts at the edges needed to be able to say something like, send this to another network. But there was no language for that.
It's like putting a
because-
postcard in another envelope.
Well, the first problem is language, because the network that you were connected to locally had no vocabulary for saying, even understanding, take this thing and send it to some other net. Every net thought it was the only net in the world.
So I have to tell you what addressing was like in the ARPANET. 16-bit addresses, when you sent something, you said, essentially send it to this wire. Imagine that every wire on the network was numbered.
Had a number.
So you said, send this to wire 17. And what was supposed to be attached to wire 17 was a big computer. So that worked fine on the ARPANET. But if wire 17 then went to some other net, which had a whole bunch of computers, which of those computers was it for? There was no way that language could
Couldn't say
describe
that.
it.
So we had to invent the
IP
Internet Protocol
addresses.
addressing.
That's where IP addresses came from.
And then we realized that in addition to that, of course, we had to make sure that all the data that we sent in these little postcard-sized pieces would be received and reassembled at the other end. And we knew that some of the networks, like the packet radio net and the Ethernet, would be lossy. You'd be in radio shadow, there'd be jamming and all kinds of things. So we had to, on an end-to-end basis, make sure that the communication was reliable. We had
So
to
how did you do that with a transmission control protocol?
Transmission control protocol. Actually, the first papers that we wrote had only one protocol. It was called TCP, and it did everything.
It had IP built in, was integrated inside.
So it had the addressing, solved the addressing problem. It solved the end-to-end retransmission and filtering out of duplicates, and flow control, and reordering, and everything was all part of the one protocol. But after a few iterations, finding some bugs in the design, several people beat us over the head and said, you know, we really need a way of delivering things really, really quickly, even if not everything gets there. So we split the Internet Protocol out from the TCP part, the end-to-end reliable part, and then created something called User Datagram Protocol so we could handle real-time traffic.
Let me ask you a question I didn't ask for the book, which is, if you had to do it all over again, knowing what you know now, what would you have designed differently?
Well, I would have started with the digital object architecture that I've been working on for the last 20 years. But that's not fair, because it's like saying, how would radio communications in this country have evolved if the semiconductor chip was available in 1915? I mean, you can't run that Gedanken experiment anymore. It's just
No,
I think
but there are things that I wish that we could have done that we didn't. Like, I wish that we had picked a 128-bit address space instead of a 32-bit address space, so we wouldn't have to go through this pain of the
What makes you
IPv6
think-
transition.
What makes you think 128 bits is enough?
Well, it might not be, but it'll be enough until after we're dead, then it doesn't matter.
What about, let me talk about more consumer-friendly things rather than addressable space, which is things like, is there too much anonymity built into the internet? Will we be better off if people were a little bit more responsible for what they put up?
I think that identity in the internet is really important. I would like to see us come to the point where everybody has unique and persistent identifiers that resolve to reasonable state information about them, and they can have multiple identities depending on the role they want to play. And one of those roles we must absolutely support, I think, is the role of anonymous.
So you'd have an anonymous, pseudonymous
You
thing.
can decide how you want to participate. If I want to participate as a government employee, I'm probably going to give a government employee identifier. If I'm going to participate as a representative of my company, that's a different one. But ultimately, I think, and then maybe the services and the opportunities you get are determined by how definitive
But in other words,
your identity
you
is.
could create an internet in which there's secure ID, and when I'm dealing with my bank, I would have to use that identity when I'm dealing with them.
Well, if this were back in 1972 and Vint and I were doing it, I would say, yes, we could do that. Today, I don't think anybody can do that anymore because there are so many places and parties around the globe who can work toward it.
I actually think it's possible to do some things to create strongly authenticated identities and also to achieve some anonymity. But we're running out of time, it turns out.
But Vint, I also agree with that. I was harping on this question about you. You said you could do it.
We got to let these other folks ask questions too. So
Having three moderators is always hard, right?
so I've got one question, Patrice,
Hey, Joyce.
and then
Thank you for
anybody
doing
else
this.
get your hands up.
This is also my wife.
I know. I saw her come in.
I'm going to throw a softball. Okay. I've been sitting here looking at your title, Innovators. I started life out years ago as a copyright attorney. I'm very much interested in the creative process. And I've heard a lot tonight about collaboration as if the spark of innovation doesn't quite matter anymore, that it's some kind of muddled group, they get together and they come up with the idea. Now, I've worked with Bob and Vint over the years, and I was listening tonight to their discussion of the early days, which that's an interesting story. But they each brought their own innovation to it. So you could have a finer level of granularity. So you can have a collaboration, but if you have a bunch of dullards and one really bright card, then the collaboration really is a useless concept. You have to look at the innovation. What is the creative force? So I'm trying to nuance a bit because I heard the drumbeat of collaboration
and that's why
a bit
it's
much.
a long book in a way, because a lot of collaborative teams don't work particularly well. I love both the RFC process and then what you all talked about the TCP/IP process, which is two people each bringing your slightly more of a communications mindset, whatever, but it ends up being a collaboration where innovation really happens. Now, by the way, that happens with Steve Jobs and Steve Wozniak. They are bringing different things to the party. It certainly happens with Andy Grove and Bob Noyce.
Yeah.
One's a Congregationalist who loves singing magical songs, in a Congregationalist church, and the other had to swim to escape the Nazis and the communists. And I even tried to do that with Benjamin Franklin because he was not the smartest of the founders. I mean, Jefferson, Madison, all. But he was the one who was the glue who could bring together a Washington who's indispensable, a passionate people like John and Sam Adams, smart people like Madison and Jefferson. And you say, okay, it's almost like a baseball team. You need a pitcher, a catcher, you need the manager, you also need utility infielders. What makes for a collaboration that has both a visionary but also executors?
Walter, who was the smartest of the founders?
The smartest of the founders may have been, I don't know, I mean, it's a good question, and smart means many different things. I think Franklin was really smart because he knew how to bring smart people together, which is a skill.
Yeah, but
I
he
think
was a twit.
Madison was intellectually, what?
He was a twit.
A twit?
Yeah.
Franklin?
Franklin. Yeah.
take
Well, I
offense.
read your book. I mean, you spelled it out.
John Adams was a twit, not
Well, I
Franklin.
don't know. He was, all right. So much for
I
that.
think Madison was the most creative mind there. Obviously, Jefferson is very fertile mind, but we don't have to get into a debate on the founders as much as I have my problems with Jefferson that go to the limits of intelligence.
Okay,
meaning-
look, let's let the audience ask questions.
Susan.
Who else
or-
has a, no, no, who else has a question here?
Oh, you're the moderator. I shouldn't be able to pick out people.
Alex Howard, I've been enjoying reading your books, following along, and using the internet for some time. I couldn't help noticing as I opened this up that you have Ken Kesey in there and Stuart Brand, who you mentioned. And if you look at the people in this book, it's an American and British story in a lot of ways. And I was, since we're in DC and people think about public policy here a lot, how you create the conditions for innovation. If you look at that story, how do you do that now as people are thinking about national competitiveness, about education, about being inclusive, because STEM is a big issue. You know the impact of you writing about this has caused quite a stir too, to recall the women of ENIAC, right? It's big important. The original computers were women, right? When you think about the conditions for innovation, what have you learned from that? And what have you all seen too in terms of the
This
things
is
we need
not
to
a
focus
question
on?
about genetics, right?
No.
Absolutely not. No, it's a condition
No,
about
this
how we
is-
create the next big thing.
But it is a question about the primordial stew from which the DNA emerges.
So at Google, I think the most important ingredient for innovation is permission to fail and the willingness to let you try crazy ideas. And the founders are willfully determined that we will push the envelope. That's why we have a Google X, and we've got moonshot experiments and things like that, like self-driving cars. I think that this attitude also shows up in the Silicon Valley, where venture capital is willing to accept risk. They know that maybe only 10% of the things they invest in will actually work out. And this is maybe, I don't think it's a peculiarly American attitude, but it is an American attitude. And I don't think we've lost that. I think we still have it, and we should use it.
And it's also true in DARPA to a large extent.
Oh, absolutely.
They shoot high and are willing to fail, even though they don't fail too often because they often don't shoot as high as they start out shooting for. So
And I'd like to ask you a question on that, which is...
a lot
Hey,
of
they're
success,
supposed to be asking questions.
a lot of success stories.
Well, I'll just make a quick statement that I think we have blown it a bit in government because it used to be you were allowed to fail, and now
or
any little
compromise.
gaffe you make in this day and age, you'll never get confirmed, you get run out of town. In Silicon Valley at least, or in other innovative places, you're allowed to fail. I have Ken Kesey in the book because there was a rebellious attitude that happens in the late 60s, early 70s in the Bay Area that involves the electric Kool-Aid acid test and Stuart Brand, but also Doug Engelbart, who, as you know, with the mother of all demos, it's almost like one of the electric Kool-Aid acid tests. It has Brand as the impresario. So part of that cultural stew was the rebellious counterculture, anti-war, anti-authoritarian, hippie, acid test mentality that has been written about by Fred Turner very well, by Steve Levy, John Markoff. Many people have written about that hacker mentality, but and it ties into the rebelliousness that allows you to fail.
So let's get 2 or 3 questions
That's right.
asked, and then we'll try to respond to them as a way of getting more on that. So let's start over here.
Hi, Jim. On the theme of collaboration, with the internet hopefully going to be accessible by the next 4 billion people of the Earth's surface and more than half the population, in terms of the global innovator community and people's ability to solve their own problems, what would you like the internet to help do in the future to solve global problems, to connect people, to collaborate on problems that seemingly are insurmountable?
Okay, so global collaboration, what can the internet do? Let's get a couple more.
I really love Steve Jobs, and the book, rather. And I'd like to ask Mr. Isaacson, what are your impressions of innovation at Apple after the passing of Mr. Jobs? Because it seems to highlight that tension between a strong, singular visionary and then a collaborative team. I think there is a storyline that there's been some drift since you lost that visionary.
Okay, so we got collaboration at Apple, and we have global collaboration over the internet. One more, if there are. If not, we'll try to tackle those two. All right, let's go after the, oh, there's one more
They're all
here.
coming from the middle.
So, Mr. Isaacson, how did you pick who the 4 people were going to be on your book cover? When you,
Yeah, okay. All right. So
I
let's,
appreciate that there's a
I don't-
woman up there.
I'm pretty sure we're not going to be able to integrate one answer to all that. Let's start with the last one, book cover. How do you do that?
Boy, it was very hard to do this book cover. I'm used to writing biographies. The Steve Jobs cover was probably the most iconic cover. It's Steve Jobs in a picture. So that's the easiest one. And when you're doing something that involves, say, 12 grand steps and 30, 40 innovators, how do you pick them? In the end, it's Alan Turing, if you're wondering who's in the bottom right. You know the others, Ada Lovelace.
Yes. So they're the bookends in some sense, and then the rich guys.
I actually, yeah. I think that Steve Jobs and Bill Gates are very, emblematic characters of how you both have vision, also you execute, and business execution is part of it, and collaboration. I mean, if I'd had 10 people, I could put 10. It was not a particularly easy cover to do. We have about, if you go back and you can find Google, things that are cached from earlier times on Amazon, there's probably 8 covers that they went through before they got to this one.
Actually, maybe you should consider publishing a book with multiple covers.
At Time Magazine, I used to do that. It was a real gimmicky, but especially every now and then you'd have
Well, the other thing that-
4 covers for 4 different.
If collaboration was the intent, I don't see collaborators on the cover at all. So anyway, just right.
Turing was a collaborator.
Well, mumble. Okay, so let's go back to this collaboration question. You've got this question of how do you use the internet to help solve global
Want me
problems?
to take that one on?
Go ahead, shoot.
So I would say you're thinking the internet writ large now. Because when I think of the internet, I think about it as in terms of the protocols and the procedures that let you connect things. So that gets back to the definition of what it is, and then you can use it for different things. And so it really gets into how people are going to get together to solve some of these global problems and what role the internet can play in it. You asked the question the other way around, what can the internet do for that? And I would say that's the wrong way to get at it. The question is, what global problem are you trying to solve? Is it clean water? In parts of the world that don't have access to clean water? Is it how to get rid of Ebola viruses? Is it how to do checkout of people in airports when they're coming in? Is it how to deal with better targeting in the field for the military? You can figure out what problem you're concerned about, and then you can figure out what a solution is, and then you can ask, is there an internet role in all of that? And most likely there will be, because everything is sort of disparate and disconnected, and you got to bring them all together. But I wouldn't phrase it exactly the way you did, starting by asking it about what the internet can do for you. It's the Kennedy thing flipped around.
Yeah, so ask not what the internet can do for you, ask what you can do for the internet. Right? So I actually want to draw out of this another notion, and that's the notion of enabling technology. Because if you look at these stories, all of them, what you see is this skein of things linking the stories together. Somebody creates something which enables someone else to do another thing. And this whole story is all about enabling, which I think is part of the origin of your question. Could the internet enable? And the thing it does better than anything is it connects stuff together that was never connected before. And this casual idea that I can take this can of Coke, for example, or this book, put a chip in it, and connect it to the internet somehow, is the beginning of ideas that people never thought of before because it wasn't possible. Now it's possible.
Maybe you don't connect it to it. Maybe it's automatically part of it when you put the chip in.
Well, if we ever get to the point where we can have self-assembling devices through biotechnology, then when people say, what do you think, computers grow on trees? And you say, yeah, let me show you. All right, let's go back to the collaboration at Apple, though, because I think that was a specific question for you to try to tackle.
Yeah, I mean, when I first started writing about Steve Jobs, I thought he was an exception to the rule about collaboration, that he was a singular visionary, and his visionary did things. And I asked him at one point, what was your most visionary thing that you created? And I thought he might say the iPhone or iPad or Mac. And he said, no, creating a particular product or having a vision for it is hard. But the really hard thing is creating a company that lasts, in which people all know how to execute with vision on various things. So the most important thing I ever created was Apple, because I realized it wasn't about me. This is him talking. I realized it was about a team of people where I could walk in and say, this sucks, or this is great, or whatever. But eventually, out of that Sturm and Drang would become a particular product. And I think the most important thing, and it's probably a way to end is here, whether it's Google or Apple or whatever else, is to look at the companies in which ingrained in the genetic code was a willingness to take risk and to fail, and importance about connecting beauty and art and humanity, making our machines more personal so we felt intimate with them. And there were a lot of companies that came up with great ideas. Xerox at Xerox PARC, Bell at Bell Labs, IBM, whatever. They didn't innovate as a team and take risks. I see Google doing that. I'm not just saying it because I'm here with you all. I mean, Google is one of the few really big companies in which it's still like, let's shoot for the moon, let's try some weird things, and let's understand the importance of teamwork. I think Apple does that. Apple still has a team. What Steve did was not just create a company. He put together people read my book and they say Steve was pretty much of a jerk at times, wasn't he? I said, yeah, but don't forget how it turns out. He has the most loyal people around him who will march through walls with him, who will collaborate, who will stand up to him. That team at Apple is a lot tighter than the teams at much friendlier companies like HP.
Walter, one of the things that doesn't show up in your book, and yet one is often drawn to the comparison between Apple and Oracle, is Larry Ellison. Is he out of the picture here because you just didn't have time to get to him, or you think he doesn't play a role here?
I don't know, you tell me.
No, you're the one who wrote the book. Why did you leave him out?
Why don't you
What
and him
is
fight?
Oracle? I did not, I don't know that Oracle was one of the 12 great leaps of the digital age. I think Larry Ellison's a brilliant person, but I don't find that the creation of the Oracle systems, was up there with the transistor, microchip, and personal computer.
That's
If I may, I would love to get
That's
back.
fair.
Yeah,
I was just
yeah.
curious as to your view.
So what Steve is able to do is really show how you get every player on a team right. Somebody like a Tim Cook who knows how to make things happen. Somebody like a Johnny Ive who understands the design. And he creates this tight team. I think at Google, too, there's this ability when you watch Larry and Sergey, but then all the people around them and all the people here. It's like we can take risks, we can take time off, we can collaborate. And I think that the most important thing for innovation is not creating the next new product, but creating the Apples, the Googles, the Amazons, whatever it may be, who are always trying to do different things.
So, I'm sorry, it turns out that this thing says 0S, and I'm pretty sure that
It's
doesn't
either
mean
0
osmium.
seconds or operating system.
Right, or something. So I have a suggestion. Why don't we finish up here? We have all kinds of refreshments out the doors here. Why don't we thank our author over here, Walter.
Let me make sure we thank the two great heroes of the theme of this book, but also of the digital age, Bob and Vint. Thank you all.
Thank you very much.